This video will do a few examples that I saw that are like ones that are on the homework. They're not the homework problems themselves, but it should give you a lot of insight into how to do some of the homework problems that I saw on the homework sheet. So, and if you have any questions, just send me or drop a comment under this YouTube video and I can make more videos. Happy to do it. Happy to explain sets and really get you going on, get started with understanding what sets are about, because you don't want to get behind now. And these concepts are actually pretty easy. It's all about getting really confused about, again, the notation, empty and null sets and what they mean. And don't get hung up on that, because sets are just about collections of objects that are not ordered. And yeah, let's get into the explanation. All right, let's work on some examples here with sets, or basic kind of where we're starting with sets. All right, so let's say we have this set 1, 2, 3, 4, and I always like to kind of think of a set like this. You know, it's the things in the group. There's 4 things in the group, and now we can start thinking about what subsets look like, proper subsets, null sets, all that. So what is the, and then we also could talk about notation. So what is the number of elements in A? Remember, that's what the n means. N is the number of elements in our set. And that's simply, how many things are in there? There's 4. Right? There's 4. Okay. Now, is the null set a proper subset of A? Is it, or for that matter, is it a subset of A? It's kind of the same question, almost the same question. So the answer to this is kind of by definition. You think about it, but the answer is yes, because when I make a subset out of my A, it's like I can pick any number of things to put over here. So, 1 and 2 is a subset. 1, 2, 3, 4 is a subset. I could take the 3 over. That's a subset. But I can also choose to take nothing. I could take nothing over, and that is a subset and a proper subset of A. The reason is because why it's a subset and a proper subset is there's 4 elements in A, and there is 0 elements in the null set. So because there are fewer elements in the null set than in A, it is a set, subset, and a proper subset. Proper subsets always have less elements. Proper subsets have, proper subsets have fewer elements than the set. Just remember that. Proper subsets have fewer elements in the set. Okay, so now what is the number of elements? So this is kind of tricky, right? I'm asking 2 things. I'm saying take the power set of A, and what is the number of elements in the power set? Well, remember from our earlier discussion, the number of elements in the power set of a set is 2 to the number of elements in the set. Right? So the number of elements, we know that the number of elements in A is 4. So that's 2 to the 4. So that's 2 times 2 times 2 times 2 is equal to 16. So we know that there's got to be 16 elements in the power subset, the power set of A. Wow. So there's got to be 16 things. So we're going to make 1, 2, 3, 4, 5, 6, 7, 8. And we're going to try and fill in all these circles with all of our combinations. Well, the first one is the empty subset. So I'm just going to, annotate that. That's like 0, nothing. Then we have each one of the 4. So we can go 1, 2, 3, 4. Now we can take 2 things. So, 1 and 2, 1 and 3, 1 and 4, 2 and 3, 2 and 4, and 3 and 4. Now we can take 3 things. So there's 1, 2, 3, 1, 2, 4, 1, 3, 4, and then 2, 3, 4. And then we can take all of them. 1, 2, 3, 4. So there's all of our 16. Sometimes it's kind of hard to figure out how to put all those patterns together, but that's all 16 of them. And so the way you'd write that out is actually like this. So the power set of A is equal to the null set, comma, the set of 1. It's not the number 1, it's the set 1, comma, the set 2, comma, the set 3, comma, the set 4 that contains 4. Now the set that contains 1 and 2, the set that contains 1 and 3, dot, 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 all the way to the set that contains 1, 2, 3, and 4. Right? The power subset always, everything inside a power set is a set. There's no elements that are the numbers. They're always sets. Okay, so that's the first key. So let's answer some other interesting questions here. So in this case, well, let's just go to example 2. So now we have this other weird thing where B is no longer. This is starting to get a little confusing. So bear with me. Bear with me here. Okay, so now B is this weird thing. It's got a set, but it's got different things inside it. It's got the elements of B are, this is a number, this is a set, and this is the empty set. Wow, crazy. So if I drew a picture of B, it's got inside it the null set, it's got inside it the number 1, and it's got inside it the set of 2, 3. So let's just think of this thing as, now we can just think of this thing as objects. So what is the N of B? How many things are inside it? Well, I see 3 things. There's 3 things. 1, 2, 3. All right. The power set of B. Okay, so just a sec. Before we talk about the power set of B, let's talk about the number in the power set of B. Well, we know if B has 3 things in it, then the number of things in the power set of B has to be 2 to the 3, or 8. So there has to be 8 things. So now let's figure out what the power set of B is. Let's draw those 8 things. 1, 2, 3, 4, 5, 6, 7, 8. Well, we know that one of them is the empty set itself. So this has nothing in it. Then we have the 3 things themselves. So we have an empty set. Then we have the number 1. Then we have the set of 2, 3. Now we have an empty set, a 1, the empty set, and the set of 2, 3. And then we have a 1 in the set of 2, 3. Now we have the empty set and a 1 in the set of 2, 3. Oh my goodness. Now remember, now we have to, when we make these into a power, when we collect all these sets and we write them as the power set of B, we have to put these things inside sets themselves. So what is this thing? This thing is, well, this thing is the empty set, which could also be written as the empty set. it is the empty set, which is also could be written as the set that contains the empty set. Oh my goodness. The set of 1 okay, this is here is the set that contains the set 2, 3. This is the set that contains the empty set and 1. Okay, this could be written like this too. Here, let's do it like this. These are the same thing. Okay, that's now we got the set that contains the empty set and the set 2, 3. We have the set that contains the set of, sorry, we have the set that contains 1 and the set 2, 3. And then we have the set that contains the empty set 1 and 2, 3. Now, I know this looks confusing and everything, and it is kind of confusing, but you just follow the model of what we did up here, where you just took all of the elements and you put each one of them, like here, when we had a 1 inside here, you put it as the set of 1. And you have a 2 inside here, that's the set of 2. That's what this whole thing represents. When I put this circle around the element 1, that is the set that contains a 1. And so that's all I did here. When I took this thing here and I put it here, that is the set. This circle is kind of like the set, and this is what the set contains. And you put that inside. All right. Yeah, it's kind of confusing, but it hopefully will start to make sense. Now here's a kind of a question that kind of comes up on the homework that may be a little bit confusing or a little bit tricky, but it's actually not. So it's basically saying, look, it has this picture here, and it says, well, if I have this set A that intersects B and has, there's some elements. So A is a set and B is a set, and it's got these elements. So A is a set, B is a set. A intersects B. They intersect, and that's got these elements J in it. And then what's L is outside of A and outside of B. So what he's asking here, so let's just kind of look at this. So remember, U is the universal set. So the number of things in the universal set, number of things equals 20 in the whole universe. So this is the universe, this big box. This is the universe. So the number of things, so the way to think about this is the things in I plus things in J plus things in K plus things in L equals 20. All right? So A, it has everything, so it is I, it is I and J. These B is J plus K, right? And then A union B is, I plus J plus K, right? So let's kind of figure this thing out. So if let's kind of write some math down here. Let's do this in gray. So we know that the universe is 20. So it's I plus j plus k plus L equals 20. Let's see. So A is 10. So A, remember, A is everything in here. So I plus j equals 10. Okay. Now we have to do a little bit of sleuthing and figure out, what does this mean? Oh, we actually never got around to this symbol, this slash symbol. So A is everything in the set A, and A, that is everything not in A. Okay? So everything not in A, so if this is A, then A naught would be K plus L, right? It's all this stuff that's outside of A. So sorry that I didn't explain that earlier, but we can keep going. So if A intersects B, so and then we're gonna have to take this not thing. But let's see, A intersects B is, well, A intersects B is J, right? So A intersects B is J. So A intersect everything that's not in A intersects B. If that's A intersects B, then everything outside of it is all this stuff. Everything out here is A not B. So that would be I plus K plus L, right? So I plus K plus L equals 17, right? Everything, the number of things not in A union B. So let's do the same thing here and see if we can figure out what this looks like. So everything not in A plus B, sorry, so let's figure out what A naught is. A naught, let's figure out what this is, then we'll figure out what this is. So A naught is equal, as we said, is equal to K plus L. And everything not in B, so if this is B, everything not in B is I plus L, right? If this is B, then everything not in B is I plus L. So now if I say the union of A, what is the union? What's the same? Well, K isn't the same, L is the same. So this is the part that's the same, so that the union is L. So I know that L equals 5. So now we should be able to figure all this stuff out. So if L has 5, then let's see. In I plus J, let's see, if I plus J is 10 and L is 5, then K has to equal 5. Right? So K has got 5. I plus J is 10. I plus L is equal to 5. I plus j is 10. So then if I plus k plus L, so then I, if k is 5 and L is 5, then I is equal to 7. So then if I is equal to 7, then j is equal to 3. There we go. So that makes sense. Okay, so it's just kind of a little puzzle that you got to put together. So the thing that you have to think about here, though, is that they want to know what I and j and k and L might be. So what you might say here is I isn't the number 7. I has 7 things in it. So you might say I is equal to 1, 2, 3, 4, 5, 6, 7. I mean, you could say, you could use anything. It could be 10, 20, 30, 40, 50, but it has 7 things in it. And j has got 3 things in it, and it's got to be different things. It can't be the same things. So it could be 8, 9, and 10, because it's got 3 things. And then k has got 5 things in it, so it could be 11, 12, 13, 14, and 15. I, J, K, and L has got 5 things in it, so it could be 16, 17, 18, 19, and 20. Okay, so hopefully that makes sense. Let me know if that doesn't make sense. So now we have this last problem. It says draw a picture of A union B prime. Well, let's draw a picture of A. So if this is our picture where we have A, and this is kind of that's kind of our intersection, and A union B would be everything in both of them. It looks kind of like this, okay? But let's just see what we got. Let's make some copies of this. Okay. Okay, so here we go. So let's go. What is A? A is this. So if we're going to draw A, B prime is everything not in B. So that's everything not in B. Okay, that's not a great picture, but maybe you do this prettier with like dashed lines or little solid lines or something like that. So A union B prime. So we want everything that's in both pictures. So union means everything over here. So that would be all of this would be included. And now B prime is everything here. So, well, what's not included in either picture? Well, this thing here is not included in either picture. So we have to then, take up this part. And there's our answer. So that's everything that's in A and everything that's in B prime. So that's A union B prime. Okay, let's see if we can make sense of this other thing here. All right, well, everything that's not in, let me use a different color maybe. So this is, so A prime, and we want B prime, and then we want to intersect that and then figure out what's over here. So everything that's not in A prime is this. Let me just try using dashed lines. This might be easier. And then here's B prime. B prime is everything not in B. And so where do those intersect? Well, there's the easiest way to do this is, well, everything that's in here, that's not, everything over here is not an intersection, because there's four parts of this picture, if you will. There's this part, there's the part that's intersected, there's the B part that's kind of only in B, and then there's the everything else part. Well, if we do like a kind of an analysis, this is not included in both pictures, so that's out. The middle section that is not included in both pictures, so that's out. And then B is not included in both pictures. So the only thing that this included, A prime intersects B prime, is everything that's outside. So that's the only part that we're going to shade. So that's A prime union B prime. All right, we'll stop there. Hopefully that helps.